Hey guys, so welcome to the lecture for geometry. Now in this particular lecture guys, we're going to be focusing on a topic known as similar triangles. So if it's something that's new to you, then I suggest you go back to your books and your teachers to really learn this concept before delving into these particular questions. So let's have a look at the very first one. It says a long piece of ribbon pegged at one end is tied to the top of a pole 8 meters away. It just touches Gary's head, who is 5 meters away from the point where the ribbon is held to the ground. Now, if Gary is 1.5 meters tall, what is the height of the pole? Okay, so let's draw this out. Again, guys, I can't really express how important it is to draw out these scenarios to really be able to delve into them. So imagine that's the pole there. There's the ribbon that's been tied to the top of it and all the way to the ground there. And it says that this is 8 meters right there. So from the pole to the point that it's been pegged to the ground, it's 8 meters. Then there is Gary, who is standing right there. And Gary is 5 meters away from the point where it's been pegged to the ground. Okay, so if I was to draw these out a little bit more neatly, that's what it would basically look like, right? So that's 8 meters for this entire bit there. That's 8 meters. And this is 5 meters. While Gary is 1.5 meters tall. So as you can see, guys, these are two different triangles that we are working with. So one has x in it because that's the height of the pole that we need to find, while the distance is 8 meters. And the other one is 1.5 meters tall with a base of 5 meters. Now, when it comes to similar triangles, guys, you might already know that what that basically means is this triangle is actually the exact same as that triangle, except its sides have just been reduced by a specific factor. Or the other way to look at it is that this particular triangle is actually the exact same as this triangle, except its sides have been enlarged or just increased by a specific factor. So using that particular knowledge, we know that we have to use ratios in order to be able to work out, what x is. So x over 1.5, so ensuring that we capture the same sides of the particular triangle, so x over 1.5 is equal to 8 over 5. So this ratio right here will tell us exactly what x is. So x is simply 8 over 5 times 1.5 using our algebra skills, and putting this straight into the calculator, I get a value of 2.4 meters. So to answer this question, what is the height of the pole? The height of the pole is 2.4 meters. Alrighty, let's move to the next question. So this particular question says, Nate, who is 1.5 meters tall, casts a shadow of 2 meters at a certain time of the day. Now, if his sister Alyssa, who is 1.8 meters tall, show that her shadow would be 2.4 meters long. Okay, so let's draw this out. We have Nate. I'm just going to draw him as a one-dimensional line, who is 1.5 meters tall, and he casts a shadow of 2 meters. Too easy. Okay, again, we are looking at a triangle here. Then we have Alyssa, who is 1.8 meters tall. Now, as you can see, guys, there's obviously not to scale. And then we have to figure out how much her shadow is going to be. We need to make sure that it's going to be 2.4 meters. All right, so again, using the same concept, we have the two sides here. So x over 2, which is equal to 1.8 over 1.5. So guys, we need to just make sure that our numerators, when we're using our numerators, are the same or come from the same triangle. Similarly, our denominators have to also come from the same triangle. It doesn't really matter which triangle we use for the numerator and which one we use for the denominator, as long as they're the same. Okay, now solving this particular one, we have x equals 1.8 divided by 1.5 times 2. Now 1.8 divided by 1.5 times 2 gives us a value of 2.4 meters. So this shows us that her shadow would indeed be 2.4 meters long. Excellent. Now let's move to the next question. Okay, so this question says, a 3-meter pole is casting a shadow that is 6 meters long. What is the height of the building that is casting a 30-meter shadow at the same time of the day? So guys, this is a very similar question to the couple of the ones that we've just done. So what I want you to do is pause the video at this stage and have a go at this particular question on your own. Okay, so we have a 3-meter long pole casting a shadow that is 6 meters long. So as you can see, the relationship between the length of the pole and the shadow that it creates is simply a factor of 2. So the shadow is simply twice as long as the length of the pole at a particular time of the day. Right? Now, if we were to look at a building, again, this is not to scale, guys. So we have a building that is casting a shadow of 30 meters. So we need to figure out what the height of the building is. So at the same time of the day, guys, the building will also be using the same sort of factor. So let's do x over 3 equals 30 over 6. Therefore, x is simply 30 over 6, which is 5 times 3, which gives me 15 meters. Therefore, the height of the building is 15 meters. Alrighty, let's move to the next question now. Okay, so this particular question says, Ruby attaches a 40-meter long string to the ground and attaches its other end to the top of a pole. Now, if Ruby stands underneath the string 8 meters away from where it's pegged to the ground, the string just touches Ruby's head. Now, if Ruby is 1.8 meters tall, how high is the actual pole? Okay, so let's first draw out this particular scenario. So again, there is a pole. She attaches a 40-meter long string to the top of the pole, to the end, to the ground. So again, it's being pegged to the ground there. This is 40 meters long. Then it says Ruby stands underneath the string. So that can be Ruby there. 8 meters from where it's pegged to the ground. So that's 8 meters right there. And Ruby, it seems, is 1.8 meters tall. So let's just quickly draw this out a little bit more neatly. So that's Ruby right there, who is 1.8 meters tall. That's 40 meters right there. And that part is 8 meters. Okay, so now let's separate these two triangles out so we can see what they look like on their own. So we have one triangle, which is the big one, which has the 40 here, and which has the x right here, because we're trying to figure out what the length of the pole is, and that is right there, the length of the pole. Then we have the Ruby part. So Ruby is 1.8 meters tall, and she is 8 meters away from the point where the string has been pegged to the ground. Okay, now guys, you might have noticed that we're actually working with different sides. So let me use a different color here. So 1.8 and x are the same side. That's a tick. That's a tick right there. However, 40 and 8 are actually not the same side. 40 is actually the hypotenuse for this triangle, and 8 is actually one of the other sides for the second triangle. So what we need to do is basically find this side, which is the hypotenuse, then use that figure to use our ratio again. And as you might have already guessed, we need to use the process, or use the Pythagoras' theorem, in order to work out that particular hypotenuse there. So a squared plus b squared is equal to c squared. So again, let me use a different color to mark the sides. So this 1.8 can be a, 8 can be b, and this part can be c. So a is 1.8 squared, b is 8 squared, and c is simply c squared. So c squared is equal to 67.24, and then c is equal to square root of 67.24, which gives us a value of 8.2 meters. Okay, so c in this case is 8.2 meters. Now we can use our ratios. Okay, so we have x over 1.8, okay, which is equal to, now we're working with the hypotenuses, so we have 40 over 8.2. Excellent. So we have x is equal to 40 over 8.2 times 1.8. Now, using the calculator, we get a value of 8.78 meters. So, if Ruby is 1.8 meters tall, how high is the pole? The pole is 8.78 meters. Okay, let's move into the final question now. Okay, so this particular question says, in a quadrilateral, two angles are equal. The third angle is equal to the sum of the two angles. The fourth angle is 60 degrees less than twice the sum of the other three angles. Find the size of the angles in the quadrilateral. Okay, so let's just quickly just draw it out. Now, I'm going to draw out a rectangular-like shape, but just, it's just a quadrilateral, and we'll pretend that these are not 90 degrees, and these are actually whatever it's been given in the question. Okay, so first let's list out the values. So first angle is, let's call it x. The second angle, as the question says, the first two angles, they're basically equal to each other, so the second can be x as well. Now the third one, it says, is equal to the sum of the two equal angles. So that's simply x plus x, which is 2x. And then we have the fourth angle, which is 60 degrees less than twice the sum of the other three angles. So the sum of the other three angles is simply 2x plus x plus x, and then twice that is times by 2, and then you do minus 60, because it's obviously 60 degrees less than twice the sum of the other three angles. So 2x plus x is 4x, times 2 is 8x, minus 60. Now guys, what do we know about quadrilaterals? The four angles in a quadrilateral actually add to give us 360 degrees. Okay, so basically what we're saying is the first, second, third, and fourth angle need to add together to give us 360 degrees. So we have x plus 2x plus, and we can put these in brackets if you like, just so we know, we're isolating them, plus 8x minus 60 is equal to 360. Okay, now using a little bit of algebra knowledge, we know that these are all like terms. So x plus 2x plus 8x gives us, I believe, 12x. Minus 60 equals 360. Then taking minus 60 to the other side as a plus. So we have 12x is equal to 420. Therefore, x is equal to 420 divided by 12, which gives me 35 degrees. So the first angle is 35 degrees. The second angle is 35 degrees. The third angle is the sum of the two, so that's simply 70 degrees, because 35 plus 35 is 70. And the fourth angle, we can simply do a takeaway of these three angles from 360. So fourth angle, or we can work it out using this particular formula here. So 8 times x, which is 8 times 35, gives me 280 minus 60, which is 220 degrees. So the first angle is 35, second is 35, third is 70, and the final one is 220 degrees. And if we were to add these all together, 220 plus 70 is 290, plus the 235s gives me 360 again. So we know that the values that we got were in fact correct. Okay guys, so that brings us to the end of the geometry chapter. As you saw, that we focused on the whole similar triangles concept, which is really quite prevalent in this kind of a year level. This particular question was more of a bonus sort of question because it sort of incorporated knowledge about quadrilaterals, which is obviously geometry, understanding that quadrilaterals all add up to 360 in terms of the angles within them. and then using some algebra knowledge in order to solve this particular question. So guys, I hope that was helpful. Please make sure that you have a go at the worksheets, and I will see you in the next lecture. Thanks, guys.